In the vast Saudi Arabian desert, an extraordinary vision is taking shape. Neom, a $500 billion mega project, aims to create a city unlike any other on Earth. Think twin skyscrapers stretching 170 kilometers across the barren landscape, rising 500 meters into the sky. This ambitious endeavor isn't merely about constructing buildings, it's about redefining urban living and setting a new standard for cities of the future. However, this grand vision faces significant hurdles. Costs are skyrocketing, with estimates for the line alone reaching over $2 trillion, far exceeding typical construction expenses in the region. The initial phase, originally planned to extend 16 kilometers, has been drastically reduced to just 2.5 kilometers, reflecting the harsh realities of such an ambitious project. Despite these setbacks, the commitment to Neom remains unwavering. The project is seen as a cornerstone in transforming Saudi Arabia's economy, moving away from its reliance on oil. Yet the question lingers, can Neom overcome its challenges and become a beacon of modern urban development, or will it fall victim to its ambitious scale? It all begins with the line, the project's crown jewel. These twin skyscrapers, planned to rise 500 meters above the desert floor and extend 170 kilometers, represent a radical departure from traditional city layouts. The concept of a vertical city aims to maximize space efficiency while minimizing the ecological footprint where the city grows upwards rather than outwards. Imagine stacking a whole city's worth of homes, offices, schools, and parks into two towering structures. By building vertically, the city can preserve the surrounding natural environment and reduce urban sprawl. But turning this vision into reality is a Herculean task. Engineers and architects face numerous hurdles. One of the first challenges is the sheer scale of excavation required. Millions of cubic meters of sand and rock need to be moved to lay the foundation. The initial stages saw thousands of trucks and diggers working around the clock, creating a logistical ballet of machinery and manpower. However, early efforts weren't without hiccups. In one instance, workers accidentally dumped vast amounts of sand in a critical area planned for a waterway to the Red Sea. This mistake required a costly and time-consuming redo, setting the project back. The foundation of the line is an engineering marvel, far beyond what traditional city foundations require. Unlike typical foundations, which support shorter, spread-out structures, the line's foundation must stretch for kilometers to support the immense weight of these towering skyscrapers. This demands intricate planning and the use of advanced materials to ensure both stability and longevity. To achieve this, engineers use deep foundation techniques. This involves driving piles deep into the ground, sometimes reaching depths of 60 meters or more, to anchor into stable bedrock. These piles are essentially long, sturdy columns made of materials like reinforced concrete or steel. By embedding these piles deep into the earth, they can provide the necessary support for the massive weight of the structures above. The scale of this foundation work is staggering. For example, just the initial 2.5 kilometer section of the line requires thousands of these deep piles to be driven into the ground. Each pile must be precisely positioned and secured to ensure the entire structure's stability. This meticulous process ensures that the foundation can bear the weight of the skyscrapers, which is comparable to stacking 60 Empire State Buildings side by side in terms of square footage. Additionally, engineers must consider the dynamic forces that will act on the buildings, such as wind, seismic activity, and the sheer weight of the inhabitants and infrastructure. Advanced materials like high-strength concrete and specialized steel are used to construct these piles, providing both the strength and flexibility needed to withstand these forces over the long term. The meticulous planning and execution involved in this phase are critical to ensuring the stability and longevity of this groundbreaking project. Another significant challenge is the construction of the building's exterior. The line's design calls for a reflective glass facade, which not only adds to the aesthetic appeal, but also helps regulate internal temperatures by reflecting sunlight. However, sourcing and installing such vast quantities of specialized glass is no small feat. The procurement of materials on this scale can drive up global prices and create supply chain bottlenecks. Moreover, the glass needs to be installed with precision to ensure structural integrity and aesthetic consistency. The interior layout of the line is equally innovative. Unlike traditional skyscrapers, which typically have a uniform design, the line is divided into distinct modules, each with its own unique design and function. These modules are intended to create diverse neighborhoods within the vertical city, providing residents with varied environments and amenities. However, this modular design poses significant engineering challenges. Ensuring seamless integration between modules while maintaining structural stability requires meticulous planning and execution. Transportation within the line is another area where innovation meets complexity. Traditional horizontal cities rely on extensive road networks and public transport systems. In contrast, the line aims to minimize horizontal travel. Instead, it will have a high-speed rail system running the entire length of the skyscrapers, enabling rapid transit from one end to the other. This rail system, along with vertical elevators and escalators, will form the backbone of internal transportation. Integrating these systems into the vertical structure without compromising space or functionality is a delicate balancing act. Sustainability is a cornerstone of Neom's design philosophy. The city aims to be powered entirely by renewable energy sources. This involves the construction of massive solar farms and wind turbines in the surrounding desert. Additionally, Neom plans to incorporate advanced water desalination plants to provide fresh water, utilizing cutting-edge technology to ensure efficiency and sustainability. The integration of these systems into the city's infrastructure is complex, but essential for achieving the project's environmental goals. One of the most significant logistical challenges is the accommodation and management of the construction workforce. Over 100,000 workers are needed to bring Neom to life, and housing them in the remote desert is no small task. Temporary worker villages have been constructed, complete with amenities like schools, medical facilities, and recreational areas. These villages are designed to provide a comfortable living environment, but they also need to be flexible to accommodate the changing needs of the workforce as the project progresses. Despite meticulous planning, unexpected challenges frequently arise. One significant issue occurred in 2020 when the project's leadership requested a shift in the alignment of the line's western end by a few kilometers to better suit the preferred terrain. This seemingly small change had a ripple effect, necessitating adjustments across the entire 170-kilometer length of the project. This shift caused months of additional work and considerable delays. Engineers and architects had to revise designs, reevaluate construction plans, and realign the entire foundation. The process involved moving heavy machinery and re-establishing makeshift roads, adding complexity to an already massive undertaking. The construction site is a hive of activity. Makeshift roads crisscross the area, facilitating the constant movement of heavy machinery. Trucks and diggers operate around the clock, contributing to a frenetic pace. The air is thick with diesel fumes from generators and vehicles, adding to the harsh desert conditions that workers must endure daily. Safety is a paramount concern. The scale of the construction and the use of heavy machinery present significant risks. Ensuring the safety of the workforce involves stringent protocols and continuous monitoring. This includes regular safety drills, the provision of personal protective equipment, and the implementation of advanced monitoring systems to detect and respond to potential hazards promptly. One of the most controversial aspects of Neom is its environmental impact. The reflective glass facade, while striking, poses a threat to migrating birds. The project's planners are aware of this and are exploring ways to mitigate the risk, such as using bird-friendly glass and implementing measures to guide birds away from the structure. Additionally, the massive scale of construction and the resources required have raised concerns about the project's overall environmental footprint. As construction progresses, the world watches with a mix of awe and skepticism. Neom represents a bold vision for the future, but the path to realizing that vision is fraught with challenges. The engineering and technical hurdles are immense, and the project's success hinges on overcoming these obstacles while staying true to its ambitious goals. Will Neom become a beacon of innovation and sustainability, or will it succumb to the weight of its grandiose ambitions? The journey is ongoing, and the outcome remains uncertain. But one thing is clear: Neom is pushing the boundaries of what is possible in urban development, setting new standards for construction and engineering on a scale never before seen. If you found this exploration of Neom intriguing, don't forget to like this video, subscribe to our channel, and turn on notifications to stay updated. Share your thoughts in the comments below. We'd love to hear what you think about this ambitious project.